So for this, you have to have learned at least one basic limit, which is limit x tends to 0 sine x over x. So we will use this result in many of the trig limits. Okay, really what that means is if you plot the sine function, right, and this is y equals x, this is the denominator and this is the numerator. And near zero, they look the same, right? Sine x and y equals x look the same near zero, right? So if you took their ratio, it's the same, right? They're equal near zero. So their ratio is 1 in the limit. That's what that means. So for limits like this, you're trying to bring in sine x over x somewhere. So can we rewrite this? What is cotangent? So x times cosine x sine x, right? So now we have it. So this is same as limit x tends to 0 cosine x times 1 over sine x over x. Do you see that? I just rewrote it, right? If you divide numerator and the denominator by x, this x will cancel out and you'll get an x here. You can separately take the limits of these and multiply them. So this one you can plug in. It's very easy, right? If you plug in here, what do you get? If you plug in 0 for cosine x, cosine 0 is 1. The cosine graph starts like this. So at 0, it is 1. Sine starts like that. So this part is 1, right? And this 1 over sine x over x. And you already told me sine x over x is, so this is 1 over 1. So this is